Welcome to the SQL Tips webcast. The more things change, DBAs versus sysadmins in cloud availability, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of SQL Tips and today's webcast host. Joining me today is David Klee, who's a Microsoft MVP and VMware vEXPERT, and Dave Bermingham, who is a Microsoft Cloud and Data Center Management MVP. And today they will discuss how to best protect SQL Server in the cloud. Before we get started, if you have questions, you can submit them any time during the webcast by entering your questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you're not already a member of the SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's webcast. At this time, I'm going to turn things over to David Klee, and he can get started.
Hi, everybody. Thank you for taking some time out of your day to watch us discuss how things change between DBAs and sysadmins, especially regarding SQL Server availability in the cloud. So like you said, my name is David Klee. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vEXPERT. I call myself the founder and chief technical exorcist of a company that we own called Heraflux Technologies. And we do a lot of performance tuning, a lot of availability, and we have a lot of fun doing this. We're kind of a company of nerds. Dave, you want to introduce yourself?
Yeah, thanks, Dave. So my name is David Bermingham. I am a Senior Technical Evangelist for SIOS Technology. Been with SIOS about 14 years. SIOS as a company is focused in high availability disaster recovery, which allows me to really have a laser focus in that area, with SQL Server and cloud really being the vast majority of what I've been focused on most recently. Beyond that, I play jazz guitar, as you can see from my picture. So I'm going to turn it back to David, and we're going to get started here. Thanks for joining.
Sweet. Okay, so we're going to start with a poll here. So what is your primary role in your organization? And I like to ask this because I really do want to figure out, how many folks on here are DBAs, how many are systems folks, and how many are kind of like me, other duties as assigned.
All right, the poll is launched, so we'll just give everybody a few seconds here to answer this, then I will read the responses.
And I always say primary largely because I was a sysadmin for a long time before I became the accidental DBA and found out I really enjoyed it and ran with it.
All right, 5 more seconds and we'll just wrap this up and I'll show the results. All right, let's see what we got here. So we have 75% database administrators, 13% other duties as assigned, 9% systems administrator, and 3% software developers.
Cool. That's a good spread. That's cool. Okay, so what we've got here is your average availability meeting. And I'm sure all of you here have had this kind of discussion at one point in time. You're talking about a new system you need to provision. The business has got some really, really strict SLAs around it. And essentially, you end up in a shouting match. So, me as a DBA, the business has to have just incredibly tight SLAs. We can only be down for a handful of seconds. The app will only recover itself if it's only down for 5 seconds or less.
And DBAs were always worried about those SLAs. Don't you know we implemented that VMware HA, and that's going to cover everything. So just relax. Us sysadmins, we have it under control.
Oh man, but we can't relax. We're moving to Azure. We can't exactly get that kind of HA that's really going to adhere to the SLAs. The SLAs are only a handful of seconds at a time. We don't even get a patching window.
Hey, did you read the marketing material? We get 99.95% availability in Azure. I mean, it's out of my hands. I don't have to deal with it. It's in the cloud. So it's going to be highly available regardless.
Highly available means, in those terms, over 7 hours of downtime a month. We can't sustain that. Do you want me to just have the phone to call you every time there's a problem? No, Nobody wants that. So you see how it goes?
I guess that's never happened. We've never had that discussion.
No, I got to say, I have this discussion at different customers of ours at least once a month, and the problem is getting everybody on the same page around what the availability requirements from the business truly are, and then turning around and conveying this in a way where each group can really understand it. Systems folks generally are out of the loop when it comes to what the business is demanding from the DBAs in terms of the database level availability. And it's tough. And a lot of times, you maybe have some maintenance windows, maybe you don't. But the unplanned scenarios are where things get really interesting. Middle of the day, hardware fails. It's a challenge. And the biggest problem that I've seen in a lot of these places, most organizations do not have a written and signed SLA document. So there's expectations, but then when you get in and really look at their architecture, a lot of times the architecture does not match the expectations. And in order to get the architecture to meet the expectations, you basically take whatever dollar amount you thought it was going to be and add a couple zeros to the end. It's not good. And if these are not written and agreed upon, you end up with these scenarios where people change when there are outages in all sides of the fence, and you end up with some real problems there. The hardest part is that a lot of infrastructure folks think, or sometimes know, that there are going to be maintenance windows for people to be able to patch, take stuff down, do upgrades, things like that. But in the data world, there are some of these scenarios where these are 24/7 systems. I mean, how do you patch a data platform underneath a life support system, or a financial system, or an e-commerce site that's available 24 hours a day? It's really, really difficult to go accommodate this. Now, from the DBA perspective, most DBAs come from a software development background, and there are anomalies out there, of course, in any of these, but most of the time in these organizations, the IT organizations are pretty well siloed, and they just don't have the visibility into what's going on underneath that operating system. So the assumption is that these components should never, ever fail. And that's a big assumption, because we know stuff fails, but things should be resilient, things should be as fault tolerant as humanly possible, but realistically, stuff's gonna fail. There's just no way around it. The biggest challenge is a lot of times the SLAs are so tight that they just boggle the mind, and reasonably so from a business perspective. It all goes back to the RPO and the RTO of whatever platform you're on and whatever business you're in. Most of the time, the expectation is as close to zero data loss as you can possibly get, which makes life really interesting if you're on a really tight budget, or if the hardware is starting to age, things like that. Plus the data, it doesn't matter if the app tier is up. If the data layer is gone, the app just sits there and is dead. So not only do we want no data loss, but we want immediate recoverability. And the longer the impact, we've got some environments where it is hundreds of thousands of dollars for every minute that these things are down, that the business loses. It's a really tough spot to be in. Now, from an infrastructure perspective, it is difficult to go buffer some of this stuff. What do you do when these different components fail? So the scope of the DBA is to look at what the SQL Server layer offers in terms of high availability. So let's go talk through some of those. So the one that's been around for a long time, SQL Server clustering. So SQL Server failover clustered instances. What that means is, we'll describe that here in a little bit, but it's a really good way to have all the contents of an instance fail between one operating system and another. Database mirroring was introduced in 2005. It's now deprecated, but it's still an option if you need it. Availability groups. These are the components that I really, really like. They work really well, but it's not the right scenario for some workloads. And, in some cases, it's a lot more costly than other scenarios. There are basic availability groups that came around in SQL Server 2016, but they're limited for a reason. They want you to upgrade to the Enterprise Edition if you need a lot of those features. So we'll talk about that here in a second. There's a combination of failover clustered instances and availability groups, and the combination of those is very powerful. We'll talk through some of that. Now, there's some folks that are actually able to use transactional replication here for an availability solution. If you've got the kind of database model that would actually support that, and you don't mind the pain of maintaining replication if there are hiccups or quirks in the environment, then it's a viable solution. But it's one of those where we see more along the lines of just moving data from point A to point B and not back and forth. And a lot of times we may use it from a reporting or a DR standpoint. Now, just for the record, the term always on does not mean the feature. Always on is a marketing term. So if you hear folks say AAG or AOAG or refer to availability groups as always on, politely correct them. It's a real easy way to sniff out, a VAR trying to sell you something they don't fully understand versus a seasoned DBA. And if they don't get the acronym right there, it's kind of a sign. So, keep that corrected there. Now, from a SQL Server failover perspective, a failover clustered, it's a really interesting setup. It's been around for a long time. So let's just say we have a two-way FCI here. So you got two copies of Windows. Now, what you do under the hood here is you have shared storage connected between them. So you can use a SAN LUN. Now, modern versions of Windows and SQL Server can leverage an SMB3 share, which is pretty cool, but it's some form of shared storage between them. Usually it's going to be a SAN LUN that's connected to both. At that point, you establish what's called a Windows Server failover cluster between the two operating systems. This gives you a virtual IP address that the application can connect into. It gives you a way to basically say who's primary, who's secondary, and at that point, then you take SQL Server and you install an FCI. What you get is one active instance, and the other instance is essentially turned off. And again, the app connects to the VIP. The Windows layer of the failover cluster is what will redirect the application server to the active copy of the SQL Server instance, and at that point, you're good to go. You can have more than one instance on an operating system here, so you could load balance with multiple active servers here. It all depends on how well you want to manage this, what sort of workload you've got in your environment, different components like that. Now, this does work really well, even if these are inside virtual machines on-prem. So you can actually do raw LUN presentation of the same thing through the hypervisor. It just passes it through and it works just fine. Hyper-V even supports shared disks, which works really well. Or again, you can still use the SMB3 share. You could also do in-guest storage presentation, largely through the Windows iSCSI initiator. It works. You have some networking stuff you got to go worry about there, and it gets a little more interesting. But they're viable solutions. But essentially, with this setup, what you've got is one of the Windows operating systems essentially owns that LUN. None of the others can actually mount it and get to it, but they can see it, they know it's there, and then you have the databases on this particular drive and everything works just fine. In the event that you want to fail this thing over, the failover cluster itself will actually disconnect the storage and will turn around and basically swing it to the other replica and then turn it on. And at that point, now the app, through the failover cluster portion, knows how to route to the second machine. It turns on and life is good. And you're looking on average between 45 seconds and a couple of minutes for a failover time there. It's solid, it's reliable, it's been around forever. It is arguably rather challenging to troubleshoot this most of the time because of the shared storage component in there. There's a lot going on under the Windows operating system that allows this shared storage to work. And if there are any sort of hiccups or quirks there, you end up with some challenges. Now, database mirroring. This one's a little more straightforward. There's Windows servers involved. You have independent copies of SQL servers between them. And if you've got a bunch of databases on that SQL server, you can set up synchronous or asynchronous mirroring to go from point A to point B. It is per database. Gets interesting. The other challenge here is that the app server itself has to know how to connect to both of these instances, and it's a maximum of 2. The biggest challenge here is that if this thing needs to fail over, the app has to know how to try to connect to A, it doesn't work, and then try to connect to the other machine. It's also a concern because if there's some sort of a hiccup in the system and one of the databases moves over but the others don't, if you've got anything inside the application that isn't aware of this sort of thing, and most aren't, anytime you start to do this, it's just flat out not going to work because all the databases need to move over together. So it's a challenge. And then, never mind the fact that this thing was deprecated as of SQL Server 2012. It's still there in SQL Server 2017. We have no idea if it's going to go away or not. So if you're on this, you need to start making plans to get off of it. Now, availability groups. These are some of my favorite features of SQL Server. It's not the right case for everything, though. It gets interesting. Now, this one is talking specifically about full availability groups. They're only in Enterprise Edition. So let's say I've got, in this case, 3 servers, Windows Server A, B, and C. What you have is independent storage. So in the hypervisor world, this is just be virtual disks connected to each one of these servers. They're treated just like regular VMs. So you install the SQL Server independently on each one. You create a Windows Server failover cluster here, but you do not configure any shared storage. So the purpose of the failover cluster is essentially to figure out who's primary, who's secondary, to figure out in the event of a failover, who needs to become primary. And then this is the thing that manages the flow of data through the availability group listeners. And I'll pull that in a second. You've got multiple databases on these particular SQL servers, but you can actually group multiple databases into one availability group. That availability group can then be synchronously replicated to another replica, or even can be asynchronous. So in this model right here, we've got 2 set up for HA with automatic failover, and 1 manual failover async for disaster recovery. Works really well. Keeps the RPO down, keeps the RTO down. Now, each availability group can be configured with an availability group listener. The listener is sort of similar to the cluster VIP before, whereas, basically that thing points to the right SQL server at the time, whatever's active. Now, the app failover in here, you're looking at an outage window on average of about 4 to 5 seconds. That really does help. And the good thing is you can have more than one availability group, each one with more than one databases in there, and you can really move this thing around. You can do multiple active replicas between different availability groups. It works out really well, but it's Enterprise Edition. There are challenges in there. If you're not running SQL Server 2017, you may be needing Microsoft DTC support. There are just some challenges with those. Now, basic availability groups are more interesting. As of, I want to say SQL Server 2016, if memory serves, they introduced this as a way, and I think it's their replacement for mirroring. What you can do here is it's similar in nature to a regular availability group, except it's only 2 replicas. So you're limited to the 2. And then it's only 1 database per availability group. So it's essentially a way to sort of strip down AGs and make them more like mirroring. For what they do, they work well. You're going to be burning through a lot of IP addresses in here if you want to set this up for a lot of databases. It is more to manage, but it's a viable solution in there if you're stuck on standard edition. Now, and then you also don't get read-write access on there. Now, to take all of that and just throw it aside for a minute, let's turn around and look at the system administrator's point of view. Functionally speaking, they hear all the buzzwords about cloud, and what do you end up getting? It's basically meaning that cloud is just virtualization in somebody else's data center, which really is what it is. There's some fancy automation in front of it, but that's about it. All they know about SQL Server is that it's an absolute resource hog. The thing is going to steal all your RAM, it's going to steal all your CPU. People get cranky when the thing gets overcommitted or taxed, and the DBAs are really, really cranky to work with. And in some cases, DBAs are, but in other cases, sysadmins are. They always go back and they say, DBAs just want more CPU, more RAM. They're eating up all my storage space. Why do we need all this stuff? Can't they just delete anything? It's kind of fun. It's kind of the IT equivalent of get off my yard. It works pretty well. In a lot of cases, what they say is good enough, high availability, is that in the event that a server fails, VM level HA restarts the VM. And we've talked about the SLAs before. The biggest challenge here comes with the expectations that are conveyed to the different layers of the business. When it comes to that level of availability, they may not be aware that the database have these kind of requirements in there. So what they, in most cases, look at are single points of failure from their point of view. So network redundancy, different configuration details, things like that. And most of the time they expect that from an application standpoint, you've got a window for patching and for planned outages, and that VM level HA is going to take care of the rest. And the assumption here is that all of your servers are virtualized at this point, because it's honestly a stretch to find reasons to actually keep something physical these days if you're still on-prem. Now, bottom line is a DBA, you do have established maintenance windows, right? So from a sysadmin perspective, everything's great, but just don't look at their networking closet. Most of the time, they turn on vSphere HA or Hyper-V HA. Everything's redundant from a storage perspective. And in some cases, you may actually have multiple SANs in order to keep things separate that way, and life is good. Everything's redundant. Things are about as good as they can get. Just don't look at their networking closet. This is a real photo that I took a year ago. Now, bottom line, stuff fails. Cloud, on-prem, whatever. This is another photo that I took. This was about a $200,000 blade server that went up in smoke. And there's this theory in electrical engineering that says all electronics are powered by smoke, because when you let the smoke out, it doesn't work anymore. This was one of those cases, and that was not a good day. It's not very fun. Hardware fails, things fail. So that's when people start looking at the cloud, because now cloud means you don't have to directly babysit cranky equipment. So let's open this up. Where is your organization at in the cloud journey? And it could be we're just getting started. It could be no way, it's not right for us. It could be we're all in and just not finished migrating yet. So let's find out.
All right, good amount of people voted so far. I'll just let it another 10 seconds here and we'll show the results.
Cool. We'll give that a few more seconds. I mean, we're in the process ourselves. I've got a lab on-prem that is a lot cheaper than going to the cloud, but all of our production stuff is out there. It's kind of the reverse that you normally see.
All right, let me close this and share the results. All right, so we have 42% said thinking about it, 33% dev and test only, 15% said they're migrating everything, and 10% said no way.
Interesting. So I've been asking this question for the last 5 years, and 5 years ago, it's kind of like virtualization was 10 to 12 years ago. When I asked how many people were ready to virtualize back then, it was a handful of folks that were really aggressive and leaning towards it, but most people were, yeah, maybe, kind of, dev test, and a number of folks were just no way. And then you look today, and virtualization is the new beige. It is the assumption across the board. So cloud, I see kind of the same way, and it's fascinating. So thank you all for voting there. And then, like we mentioned earlier, oh yeah, cloud, SLAs. Take a really good look at whatever cloud provider that you are interested in, and take a look at the availability options that they have out there. You'll kind of be shocked, which is not a good spot to be. Most of the time, what you end up is 99.99% guarantee or 99.95% guarantee. It's kind of tough because a 3 nines setup means an expectation of 7.2 hours per month that thing is not going to be available. Now, if you're a 9 to 5 shop and this stuff happens at night or on weekends, it's not a massive deal, but if you're a 24/7 shop, 7 hours really matters. And in a lot of cases, you just can't get over it. I mean, these are massive outages that we do have to go accommodate. So, when it comes to a cloud provider, a lot of the fault tolerance that the on-prem infrastructure provides today, you've got baked into it. It does just work. But now you still have to go out there and think about what can we do to increase the RPO and the RTO and really minimize the impact of the inevitable outages that will happen unexpectedly in these cloud providers. So bottom line, it works. So take a really good look with your organization and just say, hey, look at the cloud platform that you're looking at. Review it with the business. Review the SLAs. And who knows, maybe it is actually tolerable and acceptable to actually go run this stuff properly. You never know. But then take a look at the database side of it. The application servers are generally a little bit easier to go scale out than a SQL Server. Take a look at the average impact of that SQL Server and figure out what's going on with it. And then turn around and revisit the availability options that you have to you. Some of these things that were, less appealing on-prem may actually be more appealing in the clouds, or vice versa. It gets interesting. But then we got to really start to focus on what are the limitations of the platform that we're about to migrate our stuff to. So let's take a look at some of that. Now, from a failover cluster instance portion, here's our diagram, same thing as before. We don't have a good ability to do shared storage in the cloud, except maybe with the SMB3 thing. So what do? You don't get those shared disks in the cloud. How can we go accommodate this? Now, availability groups in the cloud work, but if you're going with licensing that's included with this, it's kind of tough because an enterprise edition really costs. And in a lot of cases, you don't get the ability to do host-based core licensing, which can cut some of your costs down. It gets really interesting really fast. Or if you've got a large number of databases, maybe availability groups are not necessarily the right setup for you. Or maybe there's challenges with the limitations of basic availability groups, where one database can fail over and the others won't, or, even some of the challenges around syncing and managing logins, jobs, a lot of things, or maybe there's just operating system dependencies, stuff like that you do need these things to fail over as well. It all depends on how your application and organization are structured around this stuff. But there are times where it's not a trivial operation to try to figure out which one of these can work. Well, in a lot of cases, when you look at the cloud, people are all in on availability groups on-prem, but in the cloud, sometimes FCIs maybe are a little bit more preferable. Now, what do we do there? It gets interesting. So I'm going to turn this over to Dave, and we'll go from there.
Great, thanks, David. So as David mentioned, the failover cluster in the cloud is really an ideal solution, not only for cost savings, but also for some of the technical reasons you mentioned, support for DTC in some cases, support for replicating all your user logins and passwords, your agent jobs. And in many cases, when I'm seeing customers doing migrations to the cloud, they have existing failover cluster instances on premise, and moving to the cloud is big enough change that they really don't want to introduce even more change at that time. So they're saying, well, how can we continue to use what we know and we love and we know that our vendor supports and that our engineers are trained to manage and to use, but yet still do that in the cloud. And so that's when they come to SIOS to look at our product called SIOS DataKeeper. SIOS DataKeeper Cluster Edition essentially is a solution that lets you build failover clusters without shared storage, without a SAM, which we know is an issue in the cloud. You move to the cloud, whether it's Azure or AWS or Google or any of the public cloud platforms, there is no shared storage device that is cluster aware. So you cannot typically build a failover cluster instance unless you're using something like the SIOS DataKeeper Cluster Edition, which really does two things. it does block level volume replication of locally attached storage between two or more instances, either synchronously or asynchronously. So what that does is it ensures that each instance has the same data at any given time. Synchronous replication guarantees no data loss. And if you want to stretch those clusters or the replication across regions in the cloud, or even hybrid cloud from on-prem into the cloud or vice versa, we also support asynchronous replication, which is what I call near real time. It's not, 5-minute snapshots or anything like that. It's almost, zero to minimal to no data loss. And it's a real time replication. It's very simple to set up and configure, and we'll see in a demo in a minute here. But the other piece of it is it presents a DataKeeper cluster resource to failover clustering. So as far as failover clustering is concerned, it still looks like a shared disk, but under the covers, when failover clustering detects a failure, like it normally would, or if you manually move a SQL workload from one node to another, part of that failover process, the mirror direction gets reversed so that the new active node becomes the source of the mirror, and all the remaining nodes then become the target. So it does that automatically. So really, once it's configured, it behaves like a regular cluster. And this is just a visual overview of what a typical configuration would look like. Again, this is great for the cloud. We've been seeing a huge uptick in cloud business, but we've been selling this product for many years for various circumstances. So early on, we were doing a lot of multi-site clusters, which is an issue when you have a SAN, particularly when you're not stretching sites. With our software, you could stretch sites. And then we were doing a lot of virtualization, people doing failover clustering at the guest level in VMware, trying to avoid using raw device mapping, which breaks all the other VMware features. You could build a guest-based cluster using DataKeeper and still leverage all the great VMware functionality for your clusters. But the cloud has really kind of injected a lot of new business into SIOS because of the lack of shared storage. So just like a regular on-prem implementation, you'll have your app servers connecting to your virtual cluster network name through Failover Cluster Manager. You're going to have multiple instances. As David showed you earlier in that SLA, in order to qualify, even to qualify for like 99.95% in Azure or 99.99% in AWS, you have to have at least 2 instances deployed in different availability zones or fault domains or update domains, whatever the cloud provider wants to call it, but essentially different kind of parts of the cloud that shouldn't have a single point of failure between each instance. And then once you have those instances provisioned in the different availability zones, they guarantee, well, we will give you what I term dial tone. So we will guarantee that at least one of those instances has dial tone. That's it. That's where your SLA ends. It doesn't address anything about application availability. It doesn't mention, the storage. Of course, we know, for like a front-end server, a web server, that might be good enough. You have load balance front-end web server, and if one goes down, you still have, a couple more for redundancy purposes. SQL Server gets a little bit more difficult because, well, how do we keep the data in sync? We can't just simply fail to another SQL instance. And that's for all of the technology that Dave described, where you can do availability groups, you can do database mirroring, and so forth. They all have their benefits and issues, right? One of the ways to do that is with the SIOS DataKeeper, again, with the block level replication, keeping the data in sync under the covers of the virtual disk attached to each instance, and then leveraging the true failover cluster instance on top of that to have failover. So just like you have today on-prem, we're protecting the entire SQL instance. So when you move from one node to another, everything comes, every database, all your system databases, your agent jobs, your logins, your passwords, just like regular failover clustering, full support for distributed transaction services. And the real beauty is you can do this with SQL Server Standard Edition and save a boatload of money. So there's no limitations with the Standard Edition, other than it's limited to a 2-node cluster. But even DataKeeper is not limited to simply 2 nodes in a failover cluster. We can replicate to a 3rd node for disaster recovery purposes. And as you see in this slide here, really there are no limitations in the configurations. We started in this business replicating mostly physical servers. So maybe there was some blade, you're replicating a blade from one blade center to another, or just 2, white boxes that you didn't really want to buy a SAN. But you still need some redundancy. You could build a failover cluster without a SAN. And then people looking for multi-site clusters for HA, NDR, we support that. From physical servers to virtual machines to anything. And then we moved on with the cloud. We saw a lot of people, dipping their toes into the cloud, maybe leveraging the cloud for test and dev, but also say, well, geez, we don't have to manage our own DR site. We can maybe leverage the cloud as a DR site. So we work very well in those configurations. In virtual servers, we're doing, as I mentioned earlier, VMware, especially in the earlier versions. I think they've gotten better with some of the latest releases, but a lot of times people wanted to have a little bit higher level of availability than just VMware HA. VMware HA is great for host level failures, hardware failures where an entire host goes down, but it really doesn't know anything about the operating system, the VM itself, making sure that the application is up and running and available. Not as much as you would get with a true failover cluster instance of SQL Server. So to do that with shared storage in a VMware environment, you might need to use raw device mapping, which if you do that, then all of a sudden you can't use VMware HA, you can't use vMotion, you can't take snapshots of those virtual machines, so you kind of break all the great features that you're paying for with your VMware license doing guest-based clustering. But with the DataKeeper solution, you can do guest-based clustering without giving up all those features in those virtual servers. And then high performance storage is another, when we do see physical servers, and as David mentioned, there's very few circumstances today where you really need to deploy physical servers. The only time I'm really seeing them today is where people have some super heavy-duty requirements in terms of IOPS. And they want to leverage these really fast, high-speed storage devices, usually some flash-based storage plugged directly into PCIe slot. Early on, we did a lot of work on a company called Fusion.io. It's been bought many times. I think they're Western Digital now. But anyway, so they make these great plug-in cards that the amount of IOs and the latency involved in the transactions are so low that you couldn't touch that type of speed with your typical SAN without spending multiple millions of dollars. And even then, the fact that you have to go through HBA, you're still adding latency that attaching right to the PCIe side, you just overcome a lot of that. But anyway, people leveraging those high-speed storage devices, they would leverage our software because the block level replication they found was much faster, much more efficient. Even then, the always-on availability groups, which had, especially in the earlier versions, had a severe overhead associated with it doing synchronous replication, whereas the block level replication was much more efficient and didn't have a significant impact to the IOs. So we saw a lot of people doing that with that. And then finally, what we see mostly today are pure cloud deployments where people are whole hog, they're just moving they're shutting down their data center and they're going to do everything that we used to do in the data center in the cloud. And so it's kind of lift and shift mentality, which is good and bad. I mean, the cloud has other features that are available, including lots of platform as a service, of software as a service, and microservices, all these really great things that if you were starting from scratch, you might, build your application around those services. But without totally re-architecting everything that you're doing today, then the quickest way to the cloud is that lift and shift. Like, let's take what we have and move it to the cloud, and including my failover cluster instances. So when they do that, they quickly realize I can't build my failover cluster in the cloud without SIOS DataKeeper. So we're seeing a lot of uptake of people doing that in the cloud. So Greg, if you could pass control to me, I will do a quick demo to show you how the SIOS DataKeeper solution works, and then we'll wrap this up. So I'm going to show my screen here. And I recorded this demo for sake of time. So Greg, if you're not seeing this, holler, but this is my demo. As I mentioned, it works with Failover Cluster Manager. So we have Failover Cluster Manager up and running here. I have 2 nodes in the cluster. I call them SIOS 1 and SIOS 2. That's kind of a prerequisite. You build your failover cluster just like you would any regular cluster. And this works the same on-prem or in the cloud. But once you have your cluster configured, in this particular demo, I have a SQL Server failover cluster already configured. It has its name and IP. Nothing new here, nothing unusual. Except when we look at the storage, we look at the properties of this DataKeeper, we get information about the replication right here from Failover Cluster Manager. We can see the source is SIOS 1, which makes sense because the current owner node is SIOS 1, and it's replicating to SIOS 2. We're doing some synchronous replication. It's currently in a mirroring state. I get all this information right from Failover Cluster Manager. So now I just control this like it's a regular cluster, because it is. It's a regular cluster that uses DataKeeper resource instead of a physical disk resource. So I can move that SQL workload from SIOS 1 to SIOS 2. You'll see things go offline and online. As part of that failover process, the DataKeeper volume resource is online on SIOS 2 right now, which basically means that that is now the source of the mirror and it's replicating back to SIOS 1. And so now I can show you unexpected failure if I simply just stop SIOS 2. Same thing will happen. Failover clustering will detect this type of failure and will initiate a failover to SIOS 1. So again, just kind of illustrating that there's no need to go in and have to kick anything or push any buttons or manage it any differently than you manage a failover cluster that leverages shared storage. DataKeeper will take care of all that for you. So now we'll turn node 2 back on, and I want to jump over to the interface, the DataKeeper interface, which shows you, and I'll show you how to actually get some local storage into a cluster. So this is a DataKeeper interface. That's the job that we just saw, that's for the S drive. Now it's back with SIOS 1 as the source and SIOS 2 as the target, and everything looks good. And I'm going to create a new replication job of the R drive. So we see these are all additional local attached disks to each node. Nothing special about these disks. It can be anything. In the cloud, in Azure, you're just going to add some more disk to it. It could be premium storage, a regular disk. It could be a storage space. It doesn't matter as long as it appears as a local block device and you give it a drive letter formatted NTFS, then we'll take care of it with DataKeeper. So I'm going to create this job. I'll call it the R drive. You give it a name, and then there's a 3-step wizard. You choose the source, you choose the volume. You can specify which network to use. If you have multiple networks, you can do that. And then you click next, you choose the target, everything looks good. And then finally, the last screen, we have some options here. Synchronous replication is ideal for nodes in the same region, in the cloud, or anytime you're running on the same LAN with a local area network with minimal latency. You're going to choose synchronous replication. If you want to replicate greater distances across links with more latency, you're going to want to choose asynchronous. You can also enable compression, 9 levels of compression to save on your bandwidth consumption. And you can also specify a maximum bandwidth, typically only used during the initial mirror creation process to minimize, so the DataKeeper won't consume all your WAN. Right? So for local target, we'll just choose synchronous. And we'll click done. And that goes and creates the mirror. So anything that was on the R drive will replicate from SIOS 1 to SIOS 2. And then in a moment, we get this pop-up that says, do we want to register that in the cluster? I'll say yes. Then we jump back to Failover Cluster Manager. And I see we have a DataKeeper volume R in available storage. It's coming online. Failover clustering, as far as it's concerned, that's a shared disk. It looks, feels, smells like a shared disk. So I'm going to create a file server cluster. So if I would just do my regular wizard, choose a file server for generic use, and give it a name, an IP resource. In the next screen, you'll see where it says select storage. It will recognize the DataKeeper volume as an available storage type. Same thing would happen when you're configuring SQL Server cluster. You run a SQL setup, walk through the wizard. At some point, you have to select storage. It will present the DataKeeper volume R as an available storage location. And so the experience is exactly the same. It's very simple to use and very, if you're familiar with failover clustering, I tell people, 99% of the solution. You just saw the three-step wizard. Once you've done that, everything else is failover clustering. So that's really it. That just kind of shows you how easy it is to build a cluster resource. Again, we're talking about SQL Server here today, but you really think of the DataKeeper solution as a storage solution for failover clustering. So anything you would normally put in a failover cluster, you can now put in you can build a sandwich version of it. Whether SQL Server, file servers, we do a lot of work with SAP, and we haven't really even touched on this, but SIOS also has high availability disaster recovery data replication for Linux. And something that's very interesting, I'm waiting to see the uptake in it, is SQL Server running on Linux in the cloud. The only kind of hold up right now is that there is no HA solution from either Microsoft or from the Linux providers, the distro providers, for high availability in the cloud. However, SIOS has a high availability solution. We've been selling high availability for Linux clusters since 1999. Most recently, we demonstrated building a SQL Server failover cluster running on Linux in the Azure cloud. So if you're interested in saving even a little bit more money on not only the SQL Server edition, but also on the OS. Because think about it, you're paying every hour for that Windows license. If you can do the same thing and still have SQL Server and pay a little bit less for a Linux OS, your boss is going to love you. The bottom line at the end of the year, and you're able to save the company thousands of dollars. When you go to ask for a raise, you can maybe justify a little bit, hey, may I get a small piece of that? But that is kind of greenfield. We're seeing lots of interest in that, so I'll be curious to see how that comes along. But so whether you're running on Windows or Linux, you need high availability, failover clustering, disaster recovery for Windows or Linux, any application. Definitely, was just the way to get in touch with SIOS to talk about your needs. So I'm going to turn it back to David to wrap things up. And I know that there's some questions in the queue, so we're going to take these last 10 minutes or so to address any questions you have. So make sure you get those questions submitted, and we'll hang out as long as we need to get them answered.
Okay. So kind of to wrap things up here, essentially, bottom line, throw away the technology for a few minutes. I know we love new and shiny and bells and whistles and all this, but just step back and look at it from a business perspective. What are the RPO and the RTO guarantees that the business has to have in the platform? And then take a look at the cloud platforms. If they are good enough and you've got some established maintenance windows in there, then who knows? Maybe just the stock stuff in the cloud may actually be good enough. Or, the stock VM level HA on-prem, maybe. It's probably not, but maybe. And then take a good look at the SQL Server level of HA if you need it. AGs are awesome. FCIs work really, really well. And in the cloud, DataKeeper is extremely strong. We use this all the time to go really enable folks to get data into the cloud and then to get high availability when you're up in the cloud. So I think we'll open this up for questions now.
Right, great. Thanks, guys. All right, we do have some questions. If anybody else has questions, just type them in the question area. We'll just take them one by one. So one question that came in was just about managing SQL Server as a cluster with DataKeeper. And they're just wondering, if they understand clustering, is it basically that simple, just kind of plug it in and go, or is there a lot longer learning curve to get started with it?
No, I mean, Dave, I'll mention as a representative from SIOS, I'm going to say it's easy, but David's been using the product for some of his customers as well. It really is as easy as we saw. So it's a simple, you're going to run the setup for the software. So the software is running on each node of the cluster. And that's very click, next, finish. And once it's installed, it's going to allow you to replicate any locally attached storage. So you're going to attach storage like you would any other storage device, formatted NTFS, give it a drive letter, that's it. From that point, what you just saw in the demo, where there was a three-step wizard to basically take an F drive from one server to another, create the replication, and then present that as a cluster resource called a DataKeeper volume. That's it. You saw what it takes, and then from that point on, you manage it like it's a shared disk. Everything's going to behave like it's a shared disk.
And I can definitely confirm this. We don't endorse or get behind software that we don't recommend or we use personally. This is one of those solutions that we use it a lot. We love to use it. It really is that simple. It does just work.
Okay. All right. The next question is related to the high availability DR that the cloud provides, and someone's just wondering, do they need to go through all this effort? Isn't the cloud just provide everything they need to stay online?
Well, again, it goes back to the SLAs because you can do DR to the cloud, and it's a fantastic use case for the cloud. But what happens when you actually need to fail over to the cloud? If your data center on-prem is a smoking hole in the ground, what are the SLAs for the business? And from a DR standpoint, do those SLAs transfer while running in DR temporarily? And if it's one of those things, is the business prepared to rebuild the on-prem data center and fail back? It could be a minor fault, it could be a natural disaster, it takes out the building. And do those SLAs stick when you're in the cloud? And if they do, then you do need to think about that level of HA once you're in the cloud, as well as the failback strategy there. If it's okay for the business to facilitate these sort of outages while running temporarily in the cloud, and you're going to fail back, then maybe it's okay with the business. But bottom line there, get that in writing from them. Because in the event that something happens, it's your neck that's on the chopping block for why that data layer is not up and running. And if you have their expectations in writing and agreed upon, either way, with a lot of improved HA or just leveraging what the cloud provides, then you're going to be at least personally safe.
Let's see, the next question is related to getting to the cloud. And so I'm just wondering, if they're currently on premises, is there a way they can use DataKeeper to kind of help get to the cloud? Is there some hybrid option or just the data replication?
Yeah, we have seen people leverage DataKeeper for the initial data migration. One of the issues, especially as you have larger amounts of data and you want to try to minimize the cutover time, there's some period of time where you're going to say, okay, we are going to shut down the data center and we're going to run in the cloud. And if you have an active SQL Server or any data, any sort of data repository that's constantly being written to multiple terabytes worth of data, maybe even, to get that transferred to the cloud, that's going to take some time. You can ship it. You can write to local hard drives and ship it to Azure, make it restore it. All that takes time. So what some people have done is create a real-time mirror from on-prem into the cloud of some of their data sets, so that it might take a little bit of time to get the initial synchronization done, but once it's done, any new write that occurs is automatically replicated to the cloud. So when it comes time to do the switch, the data is there. So they can just shut down the primary data center, go in, either reverse the direction of the mirror or simply delete the mirror completely. Their data is already there. So that's one less thing they have to worry about for their migration project. And of course, you can do even quicker switchover, simply do a multi-site cluster. So you add a third node to the cloud from your existing cluster, and then switch over is simply, well, bring that node online. Now you're running in the cloud. And then eventually, if you're going to shut down your primary data center, you have to figure out how to evict the old nodes and maybe add some additional nodes in the cloud as you shut down your primary data center.
Okay, thanks. Let's see. The next question is related to, can DataKeeper be used for like a web server where they have documents and images and to keep things in sync? Is it strictly for SQL?
Yeah, no, it's not strictly for SQL. If you really think about it, at the end of the day, it's very, very simple block level volume replication. So regardless of what data sits on a volume, you can replicate it from one server to another. Now, having said that, I will say that it is strictly active passive. So the data is only read-write accessible on the source, and the target drives are locked. And that locking is controlled through the failover clustering mechanism. So whatever node is the source, it becomes unlocked automatically. So typically, people are not using DataKeeper in web servers for kind of like data distribution. If you're trying to update multiple websites at the same time, it's not really used in that fashion very often. But it can really, it's not limited to just SQL. Commonly, like I said earlier, we have people doing SAP in the cloud. We have people doing file servers in the cloud. And then on the Linux side, it runs the gamut from, SAP HANA to Oracle to DB2, and you name it, any of the, major vendors in the database and applications are protected with the SIOS protection suite.
All right, another question, just limitations. Are there any limitations as far as versions of SQL Server that can work with this?
Nope, standard in enterprise.
Yeah, we see a lot of people still having to support SQL Server 2008 R2, which, David, you could probably tell me, that might be the oldest version that Microsoft still officially supports in terms of SQL Server. But yeah, it's funny, I still. What's that, David?
No, I think those are end-of-lifed.
Yeah. I mean, a lot of the versions of SQL are dictated by the application vendors. Not every application vendor is going to certify the latest, greatest version of the SQL. And sometimes you have an application that you just have not upgraded. The mentality, don't fix what's not broken, and so you're stuck. You're stuck in this, old version that you still have to support. And that's fine. SIOS in Azure specifically still supports Windows Server 2008 R2. I just did 2 implementations this week, believe it or not, on that, and SQL 2008 R2 as well. So that's kind of as old as I see. But we've been doing this since 1999. So legacy solutions way back in the NT4 days for sure.
All right, another question is related to replication and the size of databases. So somebody just says they have databases of hundreds of gigs. Is there any limitation as far as how large databases can be that can be supported?
Dave, I'll let you answer this, but first, I did just look on my phone here. SQL Server 2008 with like super mega uber extended support it is supported until July of next year.
There you go. Yeah, no, that's the beauty of block level replication. Size of database does not matter. It's just ones and zeros, blocks, ones and zeros. And the other thing is more concerning is when you're trying to consider always on, the availability groups feature versus failover clustering with DataKeeper. As David said earlier, as you grow the number of databases, so we have people come to us and they have hundreds of databases. With the availability groups, as you add availability groups and databases to an availability group, each one you add starts to consume more worker thread processes. At some point, you're going to run out of resources, and it's very dependent, of course, on your hardware and how much spare resource you have to begin with. But for a large amount of databases, block level replication is so much more efficient because we don't even know what's we don't even know how many databases you have. We're running below the file system. And so again, ones and zeros on a disk, doesn't matter how large or how many, it's going to run just as efficiently.
All right, great. Well, we're actually out of time and we're going to wrap things up. So I want to thank David and Dave for sharing all that great information today. And I also want to thank SIOS for sponsoring today's event. The webcast was recorded and you'll receive a follow-up email with links to view the archive and also to download a copy of the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending and have a great day.
Thanks, everybody.